Okay, this is nonlinear equations, okay? So nonlinear equations, you'll notice things like xy equals 6, okay? It's a hyperbola. Something like x squared plus y squared equals 16, that's a circle. Okay, so they're not straight lines. They're not y equals mx plus b or a straight line in general form. Anyway, you'll know they look different to the ones you've been doing, okay? The x's and y's aren't separated by pluses and minuses only. They've got squareds or xy next to each other, things like that. Now, for nonlinear equations, you must use the substitution method, okay? You must use the substitution method. So let's set about doing this one, okay? All right, let's set up the equations to start, okay? I've got xy equals 6. Let's call that equation 1. I've got x plus y equals 5. Let's call that equation 2. Okay. Now the aim of these questions is what you want to try and do is you want to try and isolate either the x or y and then sub it in to the equation that's not linear. Okay. So if you think about it, from 2, that equals 5 minus x, okay? Is that okay? So all I've done is taken the x over the other side. Now what I'm going to do is I'm going to substitute the y, 5 minus x, into y here, okay? So what I'm going to do is I'm going to substitute 3 into 1, okay? So what I'm going to have now is I'm going to have x, but instead of y, I'm going to have 5 minus x equals 6. Okay? And what I get now is I get 5x minus x squared equals 6. Okay? And it's starting to look like a quadratic. So I think what I'm going to do is I'm going to put the x on this side to make it all positive. So what I'm going to get is I'm going to get x squared minus 5x plus 6. Okay, so I've got x squared minus 5x plus 6 equals 0. And now I'm going to solve this quadratic by factorising first. Okay, so I think the two factors here are minus 2, minus 3. So that's x minus 2, x minus 3 equals 0. So there's two solutions. The two solutions are x equals 2 or x equals 3. Now, the next step is to go and substitute these two solutions back into one of the original equations to determine the y value. Now I'm going to sub into, I think equation 3 is actually the easiest one to sub into because the y's there waiting for you. Okay, so sub x equals 2 into 3. So y equals 5 minus 2, y equals 3. That's done. And then I'm going to sub x equals 3 into 3. So I get y equals 5 minus x, y equals 5 minus 3, y equals 2. Okay? So here are the solutions. The solutions are, here are the solutions. The solutions are x equals 2, y equals 3. And when x equals 3, y equals 2. Here's another type. This one's a bit crazy. I've got two equations here now. And if we look at the two equations, we're going to try and isolate the x and the y here and try substituting in for the x and the y here. It will probably get a little bit messy. But anyway, let's see how we go. So let's start. X squared plus y squared equals 16. Let's call that equation 1. 3x minus 4y minus 20 equals 0. That's equation 2. Okay, now we're going to have to muck around with 2. Okay, and muck around with 2 and try and isolate either the x or the y. I think I'll just make a decision to go for the y, just because maybe the 4 and the 20 they might factor out somehow. I don't know. I'm just pure guesswork. So I'll isolate the y. So what I get is, I get 4y equals 3x minus 20. Okay? So I'll write here from 2. Okay? So what that means is I'll just write them around the right way. So I get y equals 3x minus 20 on 4. Okay, so I'm going to call this equation 3. So what I'm going to do is I'm going to substitute this y value into equation 1. But instead of putting the y in, I'm going to put the x value in. That way the x's will resolve themselves. So here we go. So now I'm going to do substitute 3 into 1. Okay, here we go. X squared plus, instead of y squared, I've got 3x minus 20 on 4 all squared equals 16. How about that? So what I get now is I get x squared plus, now, square root of the first, 9x, twice their product. Well, their product, 3x times 20, is 60x, twice that, minus 120x, square root of the second is plus 400. And I've got to square the 4 as well. Gives me 16. That equals 16. Okay? What I'm going to do now is I'm going to multiply everything by 16, and that'll eliminate the denominator. So we get 16x squared plus 9x minus 120x plus 400 equals 16, so 256. Okay, just keep going down the side here, it's pretty long. Okay, I'll just collect like terms. 16x squared. I've just missed the squared sign there. Just pick that up. Square root of first, 9x squared, yes. Okay, so 16x squared plus 9x squared is 25x squared minus 120x. Now, if I bring the 256 over to this side, I get plus 144 equals 0. Okay? Now, solving this, let's have a look. I've got the square of the first, the square of the second. Is this twice their product? This is actually like saying 5x all squared minus 120x plus 12 squared equals 0. Let's just check. I think this might be a perfect square. Square root of first, square root of second, twice their product. Okay, let's check. 5x times 12 is 60, twice their product. It is, it's a perfect square. So what we've got here is we've got 5x minus 12 all squared equals 0. So I've got 5x minus 12 equals 0. So 5x equals 12, x equals 12 on 5. Now I've still got to substitute back in the original equation to find y. Now I think the best one to substitute into is equation 3. So sub x equals 12 on 5 into 3. Okay, so we get y equals 3 times 12 on 5 minus 20 on 4. Put that in your calculator and you'll get minus 3.2. Okay, so the solutions are, x equals 12 over 5 and y equals minus 3.2.